Well, hello everyone. It's been a while since we've done one of our video notes. I might be a little rusty, as I'm sure you may be too. So hopefully you'll be patient with me as we go through our new chapter, Chapter 4. Today we are going to be working on Lesson 4.1 notes, exponents, and hopefully you picked up your table of contents from the back counter today after you turned in your test. So update your table of contents, and here we go. We are going to evaluate expressions with exponents. If you don't have your calculator with you at this point in time, pause the video, go grab your calculator because you're going to need it. So today we are going to talk about exponents. If a number is in exponential form, the exponent represents how many times the base is to be used as a factor. A number produced by raising a base to an exponent is called a power. Both the number 27 and 3 to the third power represents the same power. Notice in blue, that is our base, and in red is our exponent. And again, remember, your exponent tells you how many times the base is to be used as a factor. This is not 2 times 7, which is 14. You are multiplying the number 2 times itself 7 times. Let's go ahead and write the following problems in exponential form. Our first problem that we have, 4 times 4 times 4 times 4. The base is 4. And how many times do you see the number 4? It is showing up 4 times. So that is your exponent. So we will write our first problem as 4 to the 4th power. Your second question, we have negative 6 times negative 6 times negative 6. Notice the parentheses. We're going to make sure we use it. That's negative 6. Count how many negative 6's you see to the third power. And the third question we're going to work on, 5 times 5, d times d times d times d. Now notice, we have two separate bases. We have a 5 and we have the letter d. Count how many times you see the number 5, which is twice, and count how many times you see the letter d, which is 4 times. This is our final answer. 5 to the second power times d to the 4th power. That was easy, wasn't it? Let's go ahead and move on. This is where we now will need our calculators. We will evaluate our powers. Evaluate means solve, do the math. So we have 3 to the 5th power. Do not tell me that is equal to 15. Remember, take the base. It is a factor of itself, however many times the exponent is given. So we have 3 to the 5th power, which is 3 times 3 times 3 times 3 times 3. Now let's break this up into small parts that we know. We know 3 times 3 is 9. We know 3 times 3 is 9 times 3. You should know 9 times 9 is 81 times 3. And if you need to get your calculator out, go ahead. 81 times 3, 243. I want you to solve these using order of operations. Our calculators will not keep track of everything as you multiply. So I would much rather You use order of operations, have an upside down triangle when we're all finished. Okay, so now we have -3 as our base. So -3 times itself 5 times. And again, let's multiply together what we know. A -3 times a -3 is a +9. Negative times a negative makes a positive. A -3 times a -3 is a +9. And then let's bring down that -3 that we didn't use yet. Notice, anytime we are using a negative base, please make sure to always use parentheses. 9 times 9 is 81 times -3. We have a positive times a negative. Final answer is -243. Let's try 2 more. Here we have 2 to the 8th power. Okay, give me a minute. It's going to take me a while. Whoops, I need to erase that. This is going to take me a while to write all these 8s. Why don't you go ahead and get started on this? Do I have 8? 1, 2, 3, 4, 5, 6, 7, 8. I do. Okay, again, let's multiply together what we know. 2 times 2 is 4. So underneath each grouping I am going to do 2 times 2 is 4. 4 times 4 is 16. If you have your calculator, type that in. 16 times 16 is 256. Again, by using order of operations, you are less likely to make an error rather than just typing numbers in your calculator. Our last problem on this slide, we have -4 times itself 4 times. A negative times a negative makes a +16. Negative times a negative makes, again, a +16. And 16 times 16, hey, we were just here, 256. Nice work. Okay, now it's time for us to do some order of operations with our exponents. We have x times the quantity of y to the x power minus z to the y power plus x to the y power. X is 4, y is 2, and z is 3. Let's substitute all of our numbers into the correct location. Please copy this problem down into the box that you have. Don't just try to plug the numbers in. I want you to write the x's, y's, and z's in there so you know exactly what you're doing when you go back and check your notes. We have 4. We have 4 times the quantity of 2 to the 4th power minus 3 squared, close your parenthesis, plus 4 to the 2nd power. So we must remember order of operations. Write yourself a reminder. Please excuse my dear Aunt Sally. P parentheses. Yes, we have them, but if you look inside of our parentheses, we have 2 operations. We have both exponents and we have subtraction. So we're going to start with exponents. 2 to the 4th power is 16 minus 3 squared, which is 9. I'm going to let you go ahead and do 4 squared at this point in time because we all know that 4 squared is 16. P parentheses 4 times 7 plus 16. I'm done with all of our exponents. Now let's multiply. 4 times 7 is 28 plus 16, and we get a final answer of 44. Let's try another one. This time I have some different values for x, y, and z, and I also have a different expression. Z minus 7 times the quantity of 2 to the x power minus x to the y power. That turns into 60 minus 7 times the quantity of 2 to the 5th minus 5 squared. Give yourself your reminder about order of operations. 60 minus 7, 2 to the 5th power. I'll give you a minute to calculate that one out. Pause the video so you don't see the answer. Okay, you got it? It's 32. Minus 5 squared. You should all know that one is 25. Solve your parentheses. We have 60 minus 7 times 7. Multiply. I know so many of you want to go ahead and subtract there. You're not allowed. You got to multiply first. That gives us 49, and 60 minus 49 is an answer of 11. The last portion of our lesson, we are going to apply exponents to a geometry application. We are going to find the number of diagonals in a 7-sided figure. And the way we're going to find this out is by using the expression that's been given to us. And because we have a 7-sided figure, whoops, let's try this again. Because we have a 7-sided figure, 7 is the value we are going to substitute in for n. N stands for the number of sides that a figure has. Here's our expression, 1/2. Now that's going to be 7 squared minus 3 times 7. Now I made a little mistake. I have parentheses in here twice. I'm going to change that first one to a bracket. Please excuse my dear Aunt Sally. We have brackets and parentheses, so let's use our parentheses first. 3 times 7 is 21. Then we'll do our 7 squared, which is 49, minus 21, which would make 28, and half of 28, whoops, bracket, is 14 diagonals. Now you can always go ahead and check your answer by drawing a 7-sided figure and drawing all the diagonals and counting them as you go. But we're going to use the math instead. You guys worked really hard tonight. I'm proud of you. In your book, I would like for you to try questions 2 through 14, evens only. Remember, evens only. This is on page 164 of your math book, and we'll talk tomorrow in class. Have a great night.